Okay, so this is the last presentation. Again, I thank everybody for hanging on this long. I know it's sort of a marathon of a lot of information. And so the last topic I really want to touch on is evolution, because if I had to guess, it's probably going to be the hot button issue that you're going to come across, especially when talking to atheists or skeptics. And so I kind of want to dive into, evolution, what is this theory, but then also touch on human exceptionalism, what makes us special. But before I do, I kind of want to talk about maybe a little bit of philosophy for a minute. And I'm going to kind of go through this a little bit quicker, just because of time. But the Kalam cosmological argument, it originated in the 12th century when a Muslim theologian in Persia named Al-Ghazali, I don't know if I'm pronouncing that, Al-Ghazali, he developed it initially, and then it sort of fell away. But then Dr. William Lane Craig, who some of you may have heard of, he's a research professor of theology. He sort of brought this argument back to the forefront. And basically, it's comprised of two premises followed by the argument. My mouse to work here? Okay, so the first premise is that everything begins to exist has a cause of its existence. If I build a chair, I have caused it to exist. If a tree sprouts up out of the ground, there was a cause to it doing so. So premise one, everything that exists had a cause. Okay, so if you believe that one, then the premise two is that the universe began to exist. So if you believe that these two premises are true, by default, the third has to be true as well. Therefore, the universe has a cause of its existence. It didn't just pop out from nothing, from which all matter came from nothing. First of all, that defies the laws of thermodynamics. But again, if you believe in the first two premises, then by default, you've got to believe the last one. And so this could be an interesting, not to play stump the dummy or be passive aggressive or anything like that if you're in a conversation with somebody, but perhaps mention the first two premises. Like, let me ask you something. Do you believe that this is true and this is true? And if they say yes, then you have to believe that the universe had a cause, because we know it had a beginning. Even science says it had a beginning. All right, then Craig goes on in his book, it's called On Guard, Defending Your Faith. It's a really good book. There's not really a whole lot of science in it. It's more from a philosophy viewpoint, but it's all about like logical arguments and things like that. So it's a really good book. But he goes on to state that the cause of the universe must therefore be a transcendent cause beyond the universe. It must transcend space and time, since it created space and time. Therefore, it must be immaterial and non-physical. It must be unimaginably powerful, since it created all matter and energy. It must be a personal being. And so again, I encourage you, if you ever come across the book, it's really interesting, and I think it will help having sort of those rational conversations with folks. And so in the previous two slides, we talked about influential scientists. And so now I want to talk about some that are currently living right now and doing research as we speak. And they're all Christians. And so I thought, what would be perhaps one of the most respected science institutes in the country, if not the world? And I thought MIT. So I wonder if there's any Christian scientists, not Christian Science, but Christian scientists at MIT. And I was pleasantly surprised to find that there is. And so her name is Jing Hong. She's a professor of electrical engineering and a Christian. This is Susan Hockfield, a neuroscientist and the first female president of MIT. She's also a Christian. Rosalind Pickard, she's an inventor, professor, and AI expert. Daniel Hastings, he's the department head of aeronautics and astronautics, also a Christian. Shirley Ann Jackson, she's a theoretical physicist and also the first black woman to earn a doctorate at MIT in the 60s, I believe, so that's no small feat. And then lastly, Ian Hutchinson, he is a professor of nuclear science. And so I just thought it would be good for us to see that there are Christians who are scientists who are practicing, researching, and teaching science today. And so that misconception that if you're a Christian, you can't be science-minded. If you like science, you can't believe in God. Well, that's garbage, absolute garbage. And so I find comfort in knowing that there are scientists out there who are contributing to the world that believe in God. I think that's important to point that out. And so what is the percentage of scientists that believe in God? And I think you might find this to be maybe surprising and encouraging too. And so at the top of the bar, this is actually a Pew Research Center survey that was done in 2009. So the top bar is just the general public, and then the bottom are scientists. And so you can see 33% of scientists say they believe in God. I think that's a pretty significant number considering what we're led to believe. 18% are skeptics. They don't believe in God, but they do believe in some sort of higher power or universal spirit. I mean, I'll take that. Perhaps it's a foot in the door. You know, those folks perhaps can be brought over to that 33%. You have the 41% that are atheists. They say that they don't believe in either. And I suppose that's not surprising within the science community. But what I do find interesting is for the general public, you have 1% that refuses to answer. And then you have 7% in the scientific community that refuses to answer. And I don't know for sure why that is, but I can only speculate that if you're a scientist and you're wanting to get research funding and you're wanting to teach, or maybe you're wanting to get tenure at a really fancy university, admitting that you're a Christian might not be the best idea. So I don't know for sure. That's just pure speculation on my part. But I just find it interesting that there's a difference between scientists and the general public with that. And so if there is sort of this stigma that exists, and it certainly does exist, that if you're a Christian and you're a scientist, you may have a harder time getting that research or being taken seriously. So why go into science at all? Well, French microbiologist Louis Pasteur said, because science brings us closer to God. And I think that's a really, really profound statement. And it's unfortunate because as secular science kind of takes over, it's pushing people farther away from God, whereas really it should be bringing people closer to God. And so you may know of Louis Pasteur. He's the father of modern microbiology. He developed the process of pasteurization. He also developed some of the first vaccines, which is a touchy subject. We won't go any farther into that. So let's get into evolution, a really hot button issue. So what exactly are we talking about here? So I kind of want to go through sort of its foundation and what the theory states. All right, so in 1858, Charles Darwin and Alfred Wallace published the theory of evolution by natural selection. So poor Alfred Wallace, we don't hear a whole lot about him, but he was Darwin's partner. And then in 1859, On the Origin of Species was published. And when this came out, it really was the catalyst of change for sort of this naturalistic movement within science, away from God and more towards these natural random processes. And so it says that all life is related and descended from a common ancestor. It's important to point out, when they say all life is related from a common ancestor, they're referring to all life. Bacteria, protists, animals, plants. We all came from a single common ancestor. That's what evolution is telling us, the theory of evolution. And this happens because of random genetic mutations, and if they're proven beneficial mutations, also known as survival of the fittest, they're passed on to future generations. And then as those beneficial mutations occur over time, the result is speciation, where you have one species, an individual, that evolves to a completely new species that can no longer mate with the previous species. So that's speciation. That's what the theory of evolution states. Now, to be fair, there are really two points with evolution. There's microevolution, and then there's macroevolution. Now, microevolution, we actually do see this. So microevolution can be proven. It can be seen. So there's really no debate over this. So if you're getting into a conversation with an atheist and they assume that when you say you don't really believe in the theory of evolution, make sure that you let them know, microevolution is true, we can see it. My issue is with macro, and we'll get into that. But anyway, microevolution does not involve speciation. It's just referring to a change in the gene frequency of a population. And this occurs over much shorter periods of time. And we see it with antibiotic resistance. We see it with pesticide resistance. And a really classic example is the peppered moth. And so in England, at the start of the Industrial Revolution in the 1700s, the primary coloration of the peppered moth was the light version. And so all of the trees had lichen on it that was light colored. So these light colored moths would hang out on those trees and they blended in beautifully. And the birds never ate them. Few of the individuals were a darker version. So predominantly the gene frequency favored the light individual. But there were few of the dark individuals out there. Well, at the onset of the Industrial Revolution, toxins such as sulfur dioxide killed off all the light-colored lichen. And so now when those white peppered moths would latch onto a tree, well, the birds would see them right away and pick them off. But the moths the birds didn't see were the darker variation. And so in the span of 100 years, the prevalence of the dark moths increased 1,000-fold to where they became the predominant gene frequency in the population. And so that's a perfect example of microevolution, where we see a species and we're seeing how that gene frequency is changing over time within the species. But in the end, the peppered moth is still a peppered moth. And that's the important distinction. So again, microevolution, we can see it, we can test it, we know it's real. Not so much for macro. And so when you're getting into debates or conversations about evolution, chances are you're really talking about macroevolution. And it generally refers to evolution that's above a species level. It occurs over long periods of time, millions of years, according to evolutionists. It results in speciation. Remember that new species is formed that can no longer mate with the previous species. Now, there's evidence that exists to support macroevolution, but there is absolutely nothing that proves it. And so my issue with that is that when this is taught in schools, it is taught as fact. I mean, they label it the theory of evolution, but let's be honest, the way it's taught as fact. But there is no proof that exists that supports macroevolution. And really, ultimately, macroevolution fails miserably at answering the big questions in life. And what are those big questions? So the origins of life. Where did life come from? The theory of evolution cannot answer that. The origins of body plans, and I'm going to talk about this in a little bit. The catalyst for what was a socio-cultural Big Bang that occurred, where we suddenly had this huge emergence of art and symbolic expression. The theory of evolution cannot explain that. Human exceptionalism. What makes us different than our closest genetic relative, the chimp? Macroevolution cannot explain that, as well as the origin of both eukaryotic and prokaryotic cells, all cells, the origins of sexual reproduction, and the origins of consciousness. So the theory fails to answer when it's important, right? Like, these are the big questions, these are the tough ones, and the theory fails at answering all of these. Now, I'm not going to go through all these. I will go through the first four. But all of this sort of reminds me, the fact that this is sort of taught in school as fact, and we don't really hear about the things that disprove evolution. We only hear about the evidence that suits the narrative. It sort of reminds me of Job 38, verse 2. Who is this that darkens counsel by words without knowledge? And so let's get into the origins of life. Now, I added a couple of new slides to this. Bear with me. It's going to get a little crazy. Or do you feel like it was okay? Okay. Yeah. I rehearsed it with my 15-year-old son and his 14-year-old friend earlier today. They both said they got it, but that could have been just to shut me up so they could get back to the video games. I don't know. But I did test it out on them first. So, okay. So Darwin and Wallace, they hypothesized that first life began in some sort of warm body of water, like that primordial soup we've heard of. It was filled with all of life's molecular building blocks, and it spontaneously self-assembled into a simple life form from which all other life evolved. Basically, non-life created life. That's what they're telling us. A little bit later, Carl Sagan came along. Carl Sagan was an atheist. He was an astronomer. He pushed hard for the SETI program, the Search for Extraterrestrial Intelligence, where we're spending thousands and millions of dollars trying to find life out there. He was a big catalyst for that. Well, he said, yes, Darwin was right, but that pond would have had to have been much bigger. It would have had to have encompassed all the oceans on the earth. Not only that, it would have had to have been at least a billion years needed for that spontaneous self-assembly to occur. Okay? Well, later still, a little more recently, researchers claim that the early oceans must have been really, really densely packed with the building blocks. Not just kind of packed like Darwin thought, but like super densely packed. And these molecules must be homochiral. Now, this is where I might lose you, but bear with me, please, because at the end, I think it's kind of cool. All right, so what are we talking about with chiral and homochiral? Chirality. Here's a picture of just a generic amino acid. We don't care about the elements, we don't care about the chemical bonding, but you can see it's a mirror image of one another, right? And so when molecules form, they form either a left-handed version or a right-handed version. And so when we have a mirror image, that's referred to as chirality. But what's homochirality? Homochirality is when they are the same-handedness. And so all life chemistry requires that molecules are homochiral, either that they're all left-handed or they're all right-handed. We can't have a mix in there. It's just not going to work. Okay, so we know that amino acids and sugars, specifically pentose sugar, they are the building blocks of life. Amino acids form proteins, which are necessary for cell formation and body functions. Pentose sugars are responsible for binding DNA and RNA. Here's the important part. Proteins cannot assemble unless the amino acids are 100% homochiral. They all have to be a specific handedness. DNA and RNA cannot assemble unless all pentose sugars are 100% chiral. Everybody with me so far? It gets better. All right. Whoops. All right, natural sources of these like-handed amino acids and sugars are found nowhere on Earth. The only place that they're found is in living organisms. Nowhere on Earth do we find these except in living organisms. So here's my question for the evolutionist. If homochirality is required for life, but it only exists in life, where did the first life come from? It's a pretty big question, right? The theory of evolution cannot answer that. Now, there's hypotheses, and in fact, if you remember that first slide, where I was talking about Darwin and his warm pond, well, whoops. So even later still, today, researchers now hypothesize that the source of homochiral amino acids are meteorites. I'm not joking. And to be fair, we have taken samples of meteorites and we have found some amino acids, I think like 6 or 8 out of the 23 that are necessary. We have found some homochirality that exists, but not nearly in enough of a concentration to spontaneously create life. And also, there is no evidence of those pentose sugar homochirality anywhere, not extraterrestrially or terrestrially. And so you can kind of see that as time goes on, we start with a very broad, well, any warm puddle will do. Now we're talking about meteorites being the source of life. And so I would predict that as science goes on and researches, we're going to spend millions to research this. You can guarantee that. We're probably going to find nothing. And so we'll come up with an even grander hypothesis and research that and find nothing. In the end, it all comes back to God being the creator, in my opinion. The unfortunate thing with secular science that just drives me crazy is that we're willing to go through these hypotheses, and I don't think this is a crazy hypothesis, I really don't, but we're willing to follow the evidence everywhere except when it leads to God. And that's not science. That's not true science. True scientists should follow the evidence wherever it leads them, not just when it suits their agenda. So anyway, I hope I didn't get too crazy with the homochirality thing, but just the fact that that's necessary, scientists are saying that it's necessary, but yet they're also saying, but we can't find it anywhere. Okay, well, where'd first life come from then? All right, so back to the origins of life. As I said, there's no evidence of that primordial soup. And here I'm going to get into an old age here. Again, this isn't meant to debate the age of the earth, but I want you guys to see what science is saying. So evidence shows that first life started off very complex. The earliest fossils that have been found, science has dated them to 3.8 billion years old. And they are stromatolites, which are colonies of bacteria and archaea that lived in ecosystems. And so they're living together. They're undergoing metabolic processes, that's complex. That's not simple. And so on one hand, science is telling us that these fossils date to 3.8 billion years and that they start off complex. But on the other hand, science is saying that if evolution were true, we should expect to see a very gradual from simple processes to complex. But yet the fossil record shows that it starts off pretty complex from the get-go. And again, no evidence of this gradual evolution. And in fact, the fossil record goes on to show this explosion that occurs during the Cambrian era, and we'll get into that here in a minute. So what about the origins of human life? Well, fortunately, as we learn more about genetics, advances have allowed scientists to map 2 really important genetic markers. They are Y chromosomal DNA, and that is DNA that's passed from father to son, and then mitochondrial DNA, which is passed from mother to child. And so scientists can track these markers to an origin. And they estimate an area of approximate East Africa. Now that could include parts of the Middle East as well. We don't know for sure. but it also indicates that it originates from a small population size, possibly 2 individuals. This is what science is saying. And interestingly enough, science has dubbed these 2 genetic markers, Y chromosome Adam and mitochondrial Eve. So really fascinating. So again, I would predict the more we learn about science, the closer it's going to come to pointing to God as the creator. Now, whether people follow that evidence, that remains to be seen. And so another thing that the theory of evolution fails completely at explaining are the origins of body plans. And basically, scientists believe that there's only a set number of body plans that can possibly exist. So on the far left, you've got where it says none underneath. That basically means there's no symmetry. So like a sea sponge, it's not symmetrical. In the middle, you've got the jellyfish with radial symmetry, and then you've got the cicada at the end, which is bilateral symmetry. And so all vertebrates would fall into the bilateral, and a lot of invertebrates too, with the bugs and stuff. And then here's just another example. So it's just, when we say body plans, we're referring to the very finite number of possible configurations that a living organism can have. Like, you're not going to see an organism with a leg here, an arm here, you know what I mean? If it did happen, it wouldn't live long enough to pass on that genetic material. And so, but evolution can't explain this. If evolution is just chaos and random chance, would we not see some of these bizarre sci-fi type creatures walking around? But we don't. We see a very limited number of body plans. And that's also not what the early fossil record indicates either. So I mentioned the Cambrian explosion. Scientists believe that it happened 543 million years ago. Again, it's important for you to know this date so that when you're talking to the atheist, you can say, okay, well, on one hand, you're saying 543 million years ago, but on the other hand, it doesn't really start off very simplistic. And so during the Cambrian, there was a sudden explosion or appearance of the first skeletal animals. And in fact, 50 to 80% of all animal phyla appeared within a few million years. And so what I mean by phyla, this is the taxonic tree basically here. So at the top you have kingdom. So that's going to be your broad either plant or animal kingdom. And then on down, phylum through species being the most specific of animals. So what they're saying is that 50 to 80% of all phyla, of animal phyla, suddenly appeared. That's a significant number of animals. We're not talking about 80% of species. We're talking about 80% of phyla. That's huge. And an example of that, we can see here with the fossil record. One of the phyla that emerged during the Cambrian explosion were arthropods. Arthropods are the biggest phylum that exists. They're your crustaceans, your insects, your spiders. There are more of those than anything else. I hate to say. So I know you love spiders. And see how I put insects and arachnids in 2 different, it's kind of an inside thing there. All right, so again, they appeared rapidly during the Cambrian explosion. They are our earliest known predators. Fossils that we have are complete with jaws with rows of teeth, claws, gills for respiration, and limbs for swimming. And more amazingly, compound eyes. And so this fossil and the artist's depiction of it is Animalicaris. It's an extinct arthropod that emerged during the Cambrian. And you can see that its body plan is pretty complex. It's not simplistic. The fact that it can undergo respiration, that's advanced. The compound eyes are, to me, what is really, truly unbelievable. So they're saying that this critter existed 543 million years ago. And so on the left are 3 different fossil pictures of its eye. In the bottom left, you can see the individual lenses. Now, if you imagine like a fly's eye, they have thousands of individual lenses on that eye. That's what makes it a compound eye. At the bottom here is a mantis shrimp. It currently exists, it's not extinct, but it too has a compound eye. In fact, its eye is the most complex eye in all of the animal kingdom. But you can see some similarities here. Now again, if we're to believe that evolution is true, why are we seeing highly complex structures early on in the fossil record? It doesn't make much sense. Okay, as I mentioned, archaeologists and scientists believe that there was a socio-Big Bang that occurred, they believe, about 50,000 years ago. And again, this number is important because if evolution were true, we would expect to see a gradual rise of artistic expression, symbolic language, sharing of resources, but we don't. It just emerges suddenly in the archaeological record. And those traits, by the way, the advanced tools, the art, and the sharing of resources are unique to Homo sapiens, to humans. In fact, there have been studies done on Neanderthal brains, and they've determined that the structure of a Neanderthal brain is just not capable of the advanced tools and the advanced symbolic expression. Even more than that, there were 2 recent studies that looked at the similarity of both the genomes and the gene expressions of humans and Neanderthals. And what they found was that both are genetically distinct. So that means that we did not evolve from Neanderthals. The archaeological record supports that because we don't have Neanderthals with advanced art, but then the science, the genetic piece supports it as well. They do not share a common genetic marker. So it's pretty interesting. By the way, this this cave drawing at the bottom is in France. I think they dated it to 45,000 years old, but really the point of it being up here, it's amazing to me that early primitive art, I mean, it's really good. These lions that they drew, it's impressive. I just picture somebody with their little piece of charcoal on a cave with a fire going to see. It's really amazing that our first art starts off, these aren't stick figures, they're pretty good. So then what does make us human? What makes us human? What makes us special? So DNA, does DNA make us human? Well, science says that humans and chimps share 28% of the DNA. Now some of those, I've seen some that say 60%, and I've seen some that say 99.8, so I'm just going with 98. So DNA, we share a lot with chimps. Does communication make us human? Well, we know that lots of species communicate both verbally and non-verbally. Well, what about emotion? Is emotion a uniquely human thing? Well, we also know that many species display a wide range of emotion. For anybody that owns a dog, you know a dog has emotion. Social connections, does that make us human? Well, we know that lots of species exhibit cooperation amongst themselves and even with other species. Tools, do tools make us special? Well, I mentioned the raven that used the little hook to fish a little treat out of a flask. Well, that's a tool. And they've also found that chimps will have a little toolbox, not like a literal craftsman toolbox, but they'll have a bundle of sticks, maybe 5 or 6 different size and length sticks that will be used for different functions. Maybe they want to fish some ants out of a hole over here, or fish something out of a tree stump over there. And so they do have tools and a little toolbox. So does that make us human? Because other species do that. What about self-awareness? Well, we know that there are some species that can recognize themselves in mirrors. I think of dolphins right away when I think of that, highly, highly intelligent. And so I came across, of all places, an article in Business Insider, and the author, Gus Lubin, he says, you know, it may be again that only language is what makes us human. but is it really? So yes, I said that humans and chimps share 98% of their DNA, but it's the remaining 2% that makes all the difference in the world. Humans, unlike all other species, are uniquely capable of spoken language, complete with morphology, syntax, semantics. They're only capable of symbolic communication, art, music, literature. Now I know you can, I think maybe it's India where you can go and see the elephants painting. The elephant isn't painting because it wants to paint. It's probably being coerced into doing that. So I truly believe that humans are the only ones capable of creating symbolic art. Advanced tools. So we're not talking about sticks here because sticks aren't getting us to the moon, right? So we're talking about advanced tools. An appreciation for aesthetic beauty. When you go outside and see a beautiful sunset, chimps don't do that. There's no biological reason for them to do that. Morality. I don't think that animals operate on morality. I think they operate on instinct. And so humans, I believe, are the only species capable of contemplating their morality and their mortality. I think that some animals, when they're close to dying, they know through instinct and maybe they'll separate themselves from the herd. But I don't think an animal from the very beginning contemplates when it's going to die. I think that's uniquely human. Altruism, giving freely of ourselves, that is uniquely human, as is considering life's purpose. And of course, the most important, we are innately capable of contemplating a creator. Whether you're an atheist or a Christian or anything in between, you're contemplating a higher being. It's in all of us. And so that's a part of the human exceptionalism. And so I want to point out that I was talking to Cherry that we have some friends, one who is an atheist, and I've heard this from other folks too, and I've heard it countless times in my research. Human beings were not special. There's nothing special about Earth. There's nothing special about us. We got lucky. And so I find that to be an ironic statement, because on one hand, to claim that humans are not unique, but then on the other hand, to acknowledge that we have the capacity to ponder that potential uniqueness, it's a contradiction, right? And so by making the statement that humans are innately able to understand their purpose in life, I think you're inadvertently acknowledging that we're unique and special. All right, so what evolutionary purpose does a lot of this serve? It doesn't. I mean, like I said, chimps aren't walking through the jungles, come to a clearing and see a beautiful sunset and just sit there. They're not going to do that. In fact, you could argue the opposite is true. It would go against your survival. As you're sitting around pondering the sunset, there could be a neighboring tribe coming in, or you should be out foraging and hunting. And so there's really no explanation for a lot of these uniquely human traits. And so where does human exceptionalism come from, if not from evolution? Then God said, "Let us make man in our image, after our likeness, and let them have dominion over the fish of the sea, and over the birds in the heavens, and over the livestock, and over all the earth, and over every creeping thing that creeps on the earth." So God created man in his own image. In the image of God he created him. Male and female he created them. And so where the theory of evolution and atheism, in my opinion, fails miserably, God provides the answers to the really important questions. And so when we have God, we have art, music, literature, we have altruism, advanced tools, and we are capable of contemplating our mortality. All right, so just to wrap up, 2 more slides left. I think Blaise Pascal, he was one of the scientists I mentioned in the very first slide. He said, "How can anyone lose who chooses to be a Christian? If when he dies, there turns out to be no God and his faith was in vain, he's lost nothing. In fact, he has been happier in life than his non-believing friends. If, however, there is a God and a heaven and a hell, then he has gained heaven, and his skeptical friends will have lost everything in hell. And then lastly, to quote the late, great Christian apologist and fantasy writer C.S. Lewis, he said, "I believe in Christianity as I believe that the sun has risen, not only because I can see it, but because by it I see everything." And so I would just like to conclude by saying that if you get into a conversation with an atheist or a skeptic, it's probably going to be an uphill battle. But hopefully with some of this information, you guys can both kind of be on level ground and have a rational discussion. And then I would encourage, if there are atheists or skeptics watching this lesson, I would encourage them to open their mind and open their hearts. If you are truly a science-minded person, you will follow the evidence to wherever it takes you. And I think for me, having come to God through science, I think it's important to keep an open mind and an open heart. So that's that.